Have you ever wondered how companies are building these awesome AI applications? Then you are absolutely right here, because we will dive into that topic. I will show you how these companies are building these applications and how they are able to continuously develop these applications with MLOps. I'm pretty sure that you have seen that AI is nowadays everywhere. It's really like there is no company presentation out there without saying, now we have built AI into our application. For our topic today, MLOps, it is crucial that you understand the difference between artificial intelligence, machine learning, deep learning, and generative AI. So AI is sort of the big topic that we have. It says that you have a program with the ability to learn and reason like a human. This is what artificial intelligence or AI is. So machine learning is a subset of artificial intelligence. These are algorithms with the ability to learn without being explicitly programmed. So what does that mean? So in the past, we created programs and we programmed these programs. We programmed the rules in. We said, if that input comes in, then we want to have that output. Now, with machine learning, we are not programming these rules. We say, look, we have that input and we have that output that we would like to have, and then the machine learning algorithm creates the rule set for us, but it's not anymore human readable. Deep learning is again a subset of machine learning. And here we have now a neuronal network which learns from massive amounts of data. And then we have again that subset of generative AI. And now all of these tools that you are seeing, they are using generative AI. They are learning these models with massive amounts of data. Nearly the whole internet goes into that training of these generative AI models. These terms are important to understand because everybody is talking about AI. But in the end, yes, it is AI, but it's only a very small subset of AI which we are talking about. And today we will talk about machine learning operations, or MLOps, which is a larger part of that cake. To make that a little bit more tangible, I brought you a small example which we will use during that video. I brought you a classical machine learning use case. It's the Retrieval Augmented Generation, or RAG. This is a use case that is implemented in quite a lot of enterprises nowadays. So the challenge is you have a lot of rules, compliance rules, perhaps a lot of governance documents, or you just have a bunch of documents, and what you would like to do is you would like to chat with these documents, or you would like to chat with a chatbot, and you would like to ask questions like, how do I do something in the company, or what do I need to do in order to, and then this chatbot will answer the question precisely according to the documents. So here you can see the high-level architecture of that ML use case or that Retrieval Augmented Generation use case. So what you need for that use case is quite a lot of data. You put in all of the documents, emails, everything that you want to search upon that. And you put that into a vector database. As soon as you have done that, you can implement that use case by having the user asking a question. That question will then be transferred to that database. You do a search in that database, which means you get now the documents, the relevant documents out there, which are the context of that question. And then you are going to ask the LLM behind it, so the AI behind that, with that context and that question. You are going to ask that LLM and then you get the answer for that. And this is the whole magic of such a ML use case. You would say this is an AI use case. So fine, so good. But now someone needs to implement that use case. And usually this is a developer or a data scientist that works on that use case. Here we have again a very high level architecture diagram. What we would like to have is a web interface. Then we need to have a vector database with all of the data in there, and we need to have our LLM model in there. Now, when we have implemented that locally on our machine, the question is, how do we get it into production so that every person can use it? And here, please remember that actual value or business value is only generated when something is in production. And no, we are not going to ship your machine to the users. So what we need to do is to deploy this into production. But not only that, what we need to do is also gather feedback from production and then continuously improve with that feedback from user side, but also from telemetry data, and redeploy this model in production. So now the developer or the data scientist will ask quite a lot of questions. How do I deploy that? How do I monitor? How do I do backups? How do I update the data? And how do I update also the large language models? Now let's think about having multiple of these use cases getting developed and multiple of developers or data scientists working on these use cases in an enterprise. So therefore, the big question is, how can we continuously bring these use cases, these brilliant use cases, into production? How can we do that? And here the first and most important thing what we need to think about is we should not think linear, we should think in a cycle. The first thing in this cycle is that we gather a new idea or such a use case that you just saw, and we do the development locally on our environment. And then secondly, and this is very important when we create our own models, then we want to train this model, but we don't want to do that locally on our machine. We want to operationalize the whole training. So for example, we want to do that fully automatically, for example, in a nightly basis, and we want to continuously add new data so that our model gets better and better. And then we want to deploy these models into an environment which is, first of all, accessible by others, and secondly, also scalable. Because usually what happens when such a model does a cool job or this use case is very good, then you need to scale it up quite fast and you want to be prepared for that. And then with the last point, what you want to do is continuously monitor these models. You want to know how users are using your use case or your model, what kind of data are coming into your model, what are the search queries, what are people using your model for. This is what you want to find out with monitoring. So based on that, quite a lot of questions arise in this ML lifecycle. And of course, MLOps has some answers and we are going to dive into that. So for example, one of the questions that of course arises is how can we professionally operationalize these model development? How can we have multiple versions of a model in production and, for example, doing some A/B testing with these models? And of course also, how do we scale that up and down? As I said, MLOps is the answer to that question, and as with many things, there is no clear definition what exactly MLOps is. I brought with me today the Gartner definition of MLOps, which is machine learning operationalization aims to streamline the end-to-end development, testing, validation, deployment, and instantiation of ML models. It supports the release, activation, monitoring, experimentation, and performance tracking, management, reuse, updating, maintenance, version control, risk and compliance management, and governance of models. Pooh, that's quite a big definition of MLOps. But now you will say, Romano, MLOps was yesterday. Today we have LLMops. Some of you might now say, what kind of mops? No, it's not about these mops. So therefore, let's have a look at the definition of LLMops. This is Large Language Model Operationalization, LLMops, aims to streamline the end-to-end development, testing, validation, deployment, and instantiation of large language models. It supports the release, activation, monitoring, experimentation, and performance tracking, management, reuse, update, maintenance, version control, risk and compliance management, and governance of large language models. So those of you who have paid close attention, they have found out that the definition of MLOps and LLMops is the same. And this is absolutely true because these are sort of the same things because you are going to deploy a model. Of course, there are some differences, but these are most likely nuances. And because MLOps is closely related to DevOps, we need to talk also about that. Because MLOps, like LLMops, like DevOps, is in fact a mindset, a culture, and a set of technical practices which provides communication, integration, automation, and close collaboration among all the people needed to plan, develop, test, release, deploy, and maintain a machine learning solution. Or how you would put it, an AI solution. So these three things are in fact exactly the same thing, because it is all about bringing all the people, technology, and process together to continuously deliver value to the client. Be that an application, be that a machine learning solution, or an AI solution, or a large language model solution. So when we look at that picture, it is all about delivering continuously value across that value stream, which brings us, of course, to the people. The people in MLOps are essential, and that's why we need to quickly talk about that. So the term DevOps, as you can imagine, was not so well fitted because it says development and operation. And we all know it's not only development and operation. That's why they have come up with the term DevSecOps, which is development, security, and operation. And some other people came up with the term BizDevOps, which is business development and operation. And now we have the term MLOps, which is data science and operation. And you can see this whole discussion leads nowhere. We would need a term like DevSec, Biz, Arc, Comp, DSOps to really have a good term for MLOps. The most important thing for you to understand in that picture is it is not only the data scientists and the operation people that are doing MLOps. It's really all of the people that work across that value stream who are doing MLOps. So with DevOps, we have seen the infinity symbol of DevOps. Now, when we look closely at MLOps, then this is the picture that we usually see, where we have that infinity symbol of DevOps, but we add that circle for ML to the left side of it. This means that we take DevOps, the DevOps mindset, and we apply that to machine learning, and this unifies how we develop and operate machine learning solutions. So now let's have a look into that. So the first step is, as always, the plan step, where we are going to discover new ideas in the enterprise, new use cases, new things that we can automate and bring value to the enterprise. With that, we bring all the people required together, and we start with a so-called discovery phase, where we are going to analyze that use case and also how we are going to implement that. So how should the front end look like? How should the back end look like? What kind of data do we need? What kind of people? What are the stakeholders that we need for that? Who is the user group? All of that will be looked at in the discovery phase, and out of that we create an agile backlog with all of the features in which we are going to develop. Next, we need to analyze the data for that use case. Of course, we need to extract the data and transform the data so that it is useful for this use case. Next, especially for data scientists, it's very, very important for them to do some experimentation, ad hoc trainings and evaluation of these models and also of the data. This is quite important for them because this is usually done locally, and they need to have access to the data, and they don't want to be dependent on productive systems. Next, we are going into the dev cycle, where we start to code and build and test. Here we create the pipelines, the ML pipelines, or also the CI/CD pipelines, so that we can continuously build our application and automate things. And with that, we are already going into the ops cycle, where we are going to package, the deployable artifact, which is the output out of the continuous integration, and we are going to continuously deploy that fully automatic into staging environments and into production environments, and with the feature toggles we are going to release features to our user base. And with that we are coming to a very important step in MLOps. Of course, also when you are implementing a normal application, monitoring is very, very essential, but especially in MLOps it is more essential, because what we are going to do here, we are going to extend the monitoring by ML specific monitoring, which means we also now want to monitor what kind of input, what kind of requests are coming there, and so that we can gather this information and then train based on this information better models. But of course, not only that is important, also the business KPIs are very important, because they serve as leading indicators if we are going to have a positive use case. So if this use case really adds benefit or value for the enterprise, that's why it's very important to measure these KPIs based on the initial use case or based on the hypothesis of this use case. The last state in there is the operation. Here it's very important that all of the people are working together to have a working solution. It's not about only ops is doing the operation. It's really all about cross-team collaboration, so that all of the people in the value stream are working on that software and also operating that software. Now, I already mentioned that in monitoring, but now we are going back in that cycle to the retrain, and based on the monitoring data, based on the user feedback, all of that, we are going to retrain that model so that the model gets better and better and fulfills the use case much better, so that we can increase the value add for the company. So now we go back to that ML lifecycle that we saw in the beginning, and now we can resolve all these flashes or question marks that we had in the beginning. So what we will do in model development is we are going away from these single laptop works on my machine solution and going into a solution space where we have a clean ML pipeline where we can train our models in a software engineering way with quality gates. With that, we can automate, of course, all of the processes and also operationalize the whole training of these models. And that enables us to periodically retrain our models, which means when we find a bug in our model or our software, or when we have new data, then we can regularly retrain our models without a headache. And this enables us to fully automatically deploy our models into an environment where we can do the first tests. And finally, we can deploy it into the production environment, where we are now also able to scale these models up and down. And this enables us to monitor continuously our models, but not only that, we also can now get the data that was put into these models, the questions that got asked to these models, we get that out so that they can go into the retraining. So this was quite a technology-driven view on MLOps. Let's have a look on the business view. From a business perspective, it's quite clear. We need to point out what the benefit or the value of MLOps is. So what happens when you have these MLOps capabilities and also the processes? So first of all, you have a faster time to market. You can bring models faster into production, which enables you to do experiments and bring value faster into the production. But not only that, also changes are going faster into production. A second thing which is very interesting, you will still do proof of concept with some of your models, but by applying these ML principal processes and capabilities, you are faster to bring them into production because you already have sort of standardized how you are dealing with these POCs, which means it enables you for faster experimentation. Usually in companies we have quite a lot of challenge with POCs because they work quite well on your single laptop, but as soon as you want to bring that into production, all of the problems are arising and then they don't work anymore in production. And talking about the production environment, then it is quite clear by having these capabilities, and that's the third point, you are more effective and efficient when it comes to operationalize your models. It is easier to bring new changes into production and operate also these models in production. And the last thing, which is very important, especially when you are in a regulated environments, you need to have that reproducibility, that auditability, and the compliance of your models. And this is secured when you have that MLOps process. This enables you to exactly say why an answer was given for a certain context or for a certain person. You can track it down based on what kind of model, with what data was that model trained. So you really have the full traceability of that, so that you can analyze exactly what was the reasoning of this answer. So to get all of these benefits, you need to have a set of capabilities. And for that, we need to dive a little bit deeper. So the first essential capability is experimentation. Here, your data scientists need to be able to have these ad hoc, scalable, extensible environments where they can do their ad hoc experiments. Then the next important point is the whole tracking. This capability enables you to track your ML experiments, compare the experiments, and know what kind of data or what kind of inputs you have used to train your models. This is very essential to compare different experiments and also different models. And based on that, it is very important to have these data and ML pipelines so that we can automatically regenerate our models, so that we also get these reproducible models where we can say, okay, with this input, we get that output for sure. These trained models out of the CI/CD pipeline are then stored in a model registry where we also can version these models and also add some additional data, how they are, for example, trained, or what was sort of the input data, so that we have this reproducibility. Next, we need to have that capability of a serving environment where we serve these models so that others can use these models. And as said before, the whole observability logging monitoring is very, very important, so that we get the data out there, how these models are used and how these models are performed, so that we can continuously improve these models. And as a foundation for that, we of course need version control, CI/CD pipelines, platforms, automation, and also access control. Now, when we have all of these capabilities, how does that look like in an architectural point of view? So as a foundation, we need to have a data platform, and then on top of that, we need to have that MLOps infrastructure. As a starting point, as previously discussed, we need to have that experimentation environment where the data scientists can do ad hoc experimentations. There, it's very important to track the results of these experiments. And then we need to have the data and ML pipelines, where it's very important that we write our code in a clean, reproducible way, so that we can generate these models and store them in the model registry. And these models that are registered in the model registry are then deployed into a serving environment where they are available for the consumers. And finally, as said so many times, monitoring is very, very important and is part of the serving environment. So how does that look like in a real world example? Here you can see a real world example, which is a text classification system, and it is built up in the AWS environment. So from left to right, what happens is here we gather all of the data. They are going into a streaming buffer. They are then stored, and we also create search indexes up upon this data. The data will then be used for training these models with SageMaker, and also when there is new data available, it is used for retraining this data. Here on this side, on the inference side, we will use these trained data, which has been retrained or trained here, to create these certain indexes and these dashboards, which are then used for the data consumers. And of course, around that, we need some capabilities that are very useful for, of course, this use case, but also for other use cases. We, of course, need to have a repository, CI/CD pipeline. We need to have the delivery pipelines, Docker registry, and of course, the whole monitoring. Now, here we see the tools that are provided by AWS. And it is, of course, only a subset of the tools that AWS provides for that. Now, the question arises, what kind of tools can you use for creating your ML use cases? So, when we look at the tool landscape that is out there for ML and AI tools, then it looks like this up here, and it's just huge. And if everyone in your company is just using what is out there, then you will probably have a picture like that. You will have internal developers, external developers, mixed teams that are all creating sort of their local environment with their tools that they think are the best to do the job, and you will end up with quite a huge mix in production. With that, you get huge challenges in production, because now you need to support multiple stacks in production. Also, you need to look at the security of multiple stacks. You need to automate multiple stacks. So you get quite a lot of challenges when you are going into this approach. So in summary, you have a huge tool landscape and you have a very heterogeneous distributed development environment in that version thing. So in the end, you will end with a heterogeneous distributed development environment with a huge landscape of tools. So you don't want to be sort of up there. What you want to have is a standardized, pre-selected tool landscape with a common ML stack. This will massively help you and also the teams, because they get sort of a common developer platform where they can develop their machine learning models, and it will also make the whole production environment much leaner and clearer, and it will support internal, mixed, or also external development environments. What you of course need to have for that, you need to standardize and pre-select the product. Here just an example how that can look like with the services and also the products which you need for the development, but also for ML development. So based on that, what you have seen, you can see that MLOps is a very, very important thing that you should implement. But of course, the question arises, what is the outlook? What is sort of the next level of MLOps? So first of all, Gartner also has a sort of an opinion what will happen in that AI and ML space. They are predicting that by 2026, 90% of the organization will suffer more than 10 production impacting events annually due to insufficient generative AI skills and testing investments. When you look at that, and when you also have that CrowdStrike disaster still in mind, this is not a very good thing, and therefore we need to think about how we can improve our environments, and for that a maturity model is always good, and we will have a look at that now. So here is the MLOps maturity model. We have the level 0, which is ad hoc. That's what we have discussed before, where we have some use cases which are manually, locally on your computer developed. It's individual solution. There is absolutely no traceability, and you will have quite a hard time to bring that in production. Then we have level 1, which is already emerging. There you have these ML pipelines where you start automating some of the processes, you start standardizing some of the steps, and you get some first traceability. And then on level 2, you are going into the operationalization. This is what I showed you with the ML architectural picture. There you have now a CI/CD pipeline. You are going into the direction of having full automation, monitoring, and scalability capabilities, and you are getting the ability to build robust ML or AI application which scale, but you also have the ability to have multiple of them in your enterprise. And the last level, it's the third level. This is strategic. At that point, the business sees that as a strategic investment. There you will get a platform which is centralized, standardized, optimized, and company-wide available, so that you can develop in a very standardized and governed way your AI or ML models. This of course brings us to the question, how should such a platform look like that supports our ML use cases? So when you want to have such a platform that supports your use cases, this platform needs to offer all of the tools that are needed to implement your AI or ML use cases. And you can see them up there. But it also has the capabilities that you need for these use cases. For example, application runtime, so the serving environments, the observability, the access and identity, centralized security, CI/CD pipelines, and of course, these AI and ML capabilities that we just saw. Such a platform is an internal product that is developed for the company. And it is developed and maintained and run by a platform team. The product teams, they're the data scientists, the developers, and all of the people across the value stream are working on the products. And they are creating, developing, maintaining, and also running these products. So you build it, you run it. They are really creating and taking completely care about their products. And this is a very important thing. So the platform team, they are providing this self-service portal that you can see there with all of the tools and these capabilities. They are providing that to the product teams. And the product teams, they are running and maintaining and operating their own products. It's not the platform team, and that's important. So the platform team enables the product teams to do MLOps, which means the platform team, they are generating value for the teams, and the product teams, they are generating value for the customers. So now some of you might say, but Romano, AI is everywhere nowadays, and GenAI and MLOps, all of that, and you're showing that only in that tiny little box. Yeah, let's have a look at that tiny little box. This is not so tiny. So when we enlarge that tiny box, then we offer in that platform AI and ML capability as a service. You see on top the users, the data scientists, the developer, and also the business that are using these services. Then we have a layer with the platform interfaces. There we have the portal, we have CLI, and we have APIs, and of course also especially some of these use cases that can be used by this user group. Then one level down, we have the application layer. There we have now some of the use cases like chatbots, synthetic data tools, AI coding assistants, productivity assistants. All of these are in that layer and ready to be used by the enterprise. Next, below, we have the tools. There we have prompt engineering, vector databases, RAG fine-tuning solutions, and then in the middle we have it, the model lifecycle management. There we have MLOps in there. And of course also some other toolings. And on the level below, we have the model hub where the model registry is, where we register our models. There, of course, we have models that we have self-trained, as explained before. But of course, here are also coming in these large language models, and they are stored in there so that, as I said, we can exactly say and have this traceability about what kind of inputs got what kind of outputs, which model has a better performance than the other one. That's why it's so important to have that layer. And on the bottom line, or on the foundation level, we have the AI and ML infrastructure components like compute, storage and network, but also all of the interfaces. Of course, we will have an interface to OpenAI APIs and also to AWS, Google Cloud and Azure services in there, so that we have a governed interface, a standardized governed interface for our development teams. So some of you might now say, okay, that sounds awesome, but how does that look like? Yeah, let's have a look at a real life application or a real life platform that we have built for LGT, but which we are also using at Zühlke as a platform for our development, but also for our data scientists which are doing MLOps. Let's dive into that. As said, we are developing that together with LGT. LGT has their own instance of the platform plane. We at Zühlke have our own instance of the platform plane, and this is what you see when you log in into the platform plane. So when you have such a platform, it gets very easy to implement such AI use cases. It's just like playing Lego with MLOps, and that's quite an awesome thing. And I will show you now some of the things that we have built based on that platform or with the support of that platform. So the first thing that I want to show you is the documentation. You have a documentation about the platform, but you don't need to read the documentation. You can ask our AI assistant here about the documentation. For example, how to connect to the cluster, for example. And he will now go as in the example. This is just a RAG case, as we saw it also in my example. This is exactly this example where you have the documentation in a vector database, and behind that you have a large language model which now answers these questions. And creating that took us nearly no time, because as I told you, as soon as you have such a platform and you have all the capabilities in place, it's just like playing Lego and sticking the things together. So this is already quite an interesting use case, but I want to show you also another one. We have here a reference finder, so this is also a RAG model that we are, or a RAG use case that we have implemented here. And when I click on that, this is a space where projects are being developed, and here in that case it's the reference finder MVP that we use for Zühlke, so it's a sort of an internal project. We have here the infrastructure with the code which is developed, and here we have the registry. So the containers get registered also in this platform. We have here the backend, we have here the latest container, and we can click here on layers, and here we again have an AI behind that. That's now a large language model from Red Hat, which can analyze Docker images. And again, here it's just playing Lego, plugging it in, and you get these nice use cases, which our developers are very, very happy with that. So now let's have a look at when we go back here. We can go to the platform itself. So here we are now on the Kubernetes cluster itself, and we see here the different Docker containers that are running. So this is a productive environment that we see here. We see here the front end, and I click on the front end, and immediately here is the link to this reference finder. So the reference finder is an important application for us to find references about our application. So I can give in here, GenAI, and it finds references, project references for us at Zühlke for GenAI now. So creating these applications, these use cases is with such a platform a very easy thing, because as you can see, you get everything out of the box. You get CI/CD pipelines, you get version control, you get observability. By the way, about observability, let's have a look at exactly observability. When we go back here, then we see here the front end. We can open the log files, and boom, there are the log files of this container, or of these many containers. As a data scientist or as a developer, you usually need to have, for example, a database. And when you have such a platform, you can just click on Add Application, and then your service catalog comes up. This service catalog enables now the data scientists or the developers to, for example, add a MySQL database, MongoDB, or a Kafka right in a standardized, governed way, which means that the naming schema of the company will be applied. All of the rules, compliance rules, security rules, network rules will be fully automatically applied. Also backups and logging and monitoring will fully automatically be applied when I add such a service. And this is such a time saver. It is just unbelievable. And of course, you can also simply add or run your own container if you want to do that, but that is usually not the real use case that you have with such a platform. And again, here we can also see that we have Anaylze Logs here, and again, this is just another large language model that is specialized for log analysis, and with that you can analyze all of the log files. And now you can see the power of such a platform. When you have such a platform, all of the data is in that platform. You have the log files, you have the CI/CD pipeline, all of the capabilities right at your fingertips, and this enables you to be much faster in such developments. Let's have a look at another use case that another team has implemented. This is the so-called ZenAI. Again, here you can see the repositories that are there, the registered containers that are already there, and here we are then on the platform itself. You see how this is structured. We have here the multi-app, and we can now log into this application. This application, as said, is really about the enablement of the Zühlke employee. You can see we have different use cases in there where I quickly want to show you what the power is of AI and MLOps when you have such a platform, because you can build these absolutely awesome things in no time. So one of the first use cases that they have implemented is that AI chat with file and web search, where you can choose a model. And here again, now you can see the model registry and how that's working, where you have the different models below it. We go here with OpenAI GPT for Omni. Then we have different prompt templates in here. We take helpful assistant. We even can edit the system prompt. We can have here choose a prompt. Let's go with a simple one, the market technology investment decision. We get here that prompt. I could also upload some files, and now I can say MLOps. So check if the technology MLOps is worth investing, and we can go with that. And now it will give us the output based on that, if MLOps is a good investment decision. And they also have implemented other use cases, like for example a research assistant, where we for example can go and say, hey, research about MLOps, for example, and the research assistant will do that. We can even edit here the description, the output format, like the LLM Teams, easy to understand, IP, MLA or Chicago output format, and then you have a research assistant with a specific, of course, system prompt that fits our needs. And the last one that I want to show you is the company analyzer. This is also a very handy thing when you are going to sort of a new customer. Here we can analyze other companies in a very defined way, and you can see now the informations are rolling in, and you can see the company overview with revenue, employee count, and so on are being shown here. It's really an absolutely handy thing for our Zühlke employees. Having such a platform is absolutely awesome because it enables you to do fast experimentation in a very strategic, scalable, and also standardized environment, which enables the developers but also the data scientists to focus on their work and not on all the other things that are around that. And this is really an absolutely game changer to have such a platform, because you have a much faster time to market and you can bring new use cases much faster to the market than without such a platform. Let's have a quick look at the architecture of the platform so that you understand how such a platform is architected. On the top, you have all of the people that are working with such a platform. You have the CLI, you have the web interface or the portal, the self-service portal for the teams, and you have all of the tools that the teams are using. The most important thing about such a platform is you are not going to hide anything away from the developers. You just integrate everything into this platform so that it is easy to use for the developer or for the data scientist. On the bottom line is a very important thing. It's the adapter concept, where you just plug in all of the tools and also of the models, all of the capabilities. They are just plugged in, and they are then used in unified integration blocks, for example, for registry, for artifacts, or for models, and then you have the unified API, which serves then the user interface. With that, with such a platform and with that concept of these adapters, you can very easily replace some of the tools, but also add new tools to such a platform. But now the question is, how does that work with the MLOps examples that we just saw? Let's have a look to that. So these examples that you just saw, for example, the ZenAI use case or even the reference finder use case, this is sort of the top use case, where you have a web application that is developed by some of the developers and is using the platform. The other one is that's what you saw with the log analysis or the Docker image analysis, which are use cases that are used by the developer and are part of the platform itself. Both use cases are using this unified API where you have the files, the vision, the audio and the chat on that API, where you then level below have authentication and auditing with function calling, agents, classifications and categorization, and the retrieval augmentation and generations, which are the building blocks that you can reuse in such a platform. And then we are on the interface level. There we have the completer with the providers that are providing the interfaces for this completer. And there we have SaaS offerings like OpenAI, which you could see that they could choose it. But of course, you also have on-prem solutions, on-prem models like the Llama, Mistral model. And this is very important to offer on-prem and SaaS-like, because sometimes you have customers or sometimes you have just data that you don't want to expose in the internet, which you need to have on-prem. And when we talk about the completers, this is the use case where you have text completion. That's why we have these models here that we are using for that. Then we have the embedder. Here we are going to embed things into a vector database. And here we again have SaaS offerings from OpenAPI that we are using, but we are also using models like SBERT. And the third one is the transcribers. This is used to transform voice into text. Again here, SaaS-like, we are using OpenAI, and on-prem we are using models like Whisper. And the last ones are the indexers. This is important for the vector databases so that they can get indexed, so that we can search. You remember the use case that I showed you. There we use Pinecone, and on-prem we use ChromaDB or VV8. So you perhaps remember back the big picture of the platform and that small AI ML box there for the capability. This is sort of how that looks like architecture-wise, and you now also saw how this is implemented. And of course, when you have such a platform, more and more ideas are coming to your mind which accelerate your business. This brings us to the summary of this video. You could see that MLOps, LLMops and DevOps, they are sort of all of the same. Of course, they have different flavors and different needs, but in the end, it's all about bringing all the people, process and technology together to continuously deliver value. This is what MLOps is in the heart, and of course also DevOps. Then we talked about the MLOps lifecycle. Here it's very important. We don't want to have these local environments. We want to have a clear environment where we can develop and experiment with these models. Then we want to have that deployment and operationalization so that we can retrain also our models. And then the whole monitoring is a very important thing for this MLOps lifecycle. When it comes to MLOps capabilities, it's very important for the data scientist to have an environment, standardized environment, where he or she can do the experimentation and then also track these experimentations. So know what were the input, what was the model, what was the output, so that we have the traceability on these experimentations, so that we can evaluate which model is the best one, has the best performance, and then a full automated pipeline so that we can automatically deploy these models into a production environment and monitor these models. We also saw that of course, there is an MLOps maturity models where 0 is ad hoc, and then you get better and better. And the really top end, there you have a platform in your enterprise which provides you with all of these capabilities which you need to do MLOps. And you saw, by having such a platform strategy, having such a platform which offers you these MLOps capability, you have a massive strategic advantage because you are much faster in bringing new ideas into production. We saw that AI is nowadays everywhere, and to build these absolutely amazing AI solutions, you need these models, and for that you need to have MLOps in place. And to do MLOps efficient, you need to have a fully automated pipeline with automated deployment, with the monitoring, and in the best case, you have a platform that has all of these capabilities together. And this is the strategic lever which you need for your innovation and efficiency. And you see, this is the way how you can continuously deliver your machine learning systems or AI systems into production and continuously deliver value for your clients.